Manage everything. Okay. So we got 4x equals 41. Simple equation, 4x equals 41. We divide both sides by 4. You know that 4 is going to go away, but I want to be sure you understand why it goes away. So I recommend that you understand what I'm telling you is that, which is that 4x over 4 is the same as 4 over 4 times x over 1. Okay? Because when you multiply fractions, you multiply numerators and multiply denominators. So this is clearly equal to this because 4 times x is 4x and 4 times 1 is 4. Well, 4 divided by 4 is 1. And dividing x by 1 gives you x. And multiplying what you got by 1 then still gives you x, right? So multiplying or dividing by x doesn't change anything. And you get x equals 41 over 4. So these two steps here, people are kind of trained to skip them. But there's something that people do, which is cancellation. And people always do it wrong. Almost everybody screws up cancellation. Probably not on a problem this simple, but on other problems, people don't understand the rules for cancellation. If you can't do this, you can't cancel. Okay. Now I'm just going to skip these steps. I'm going to replace these steps by 3 dots when I solve the rest of them. But you want to think through these steps. At first, you want to think them through pretty much every time you solve an equation. You want to remind yourself of why that 4 goes away, not because of a rule for cancellation. Because again, very few people at this stage, whether enrolling for this course or pre-calculus, even calculus students, do wrong cancellations. And we want to clarify that. Okay, so anyhow, let's take this 4x plus 7 equals 15. Well, you subtract 7 from both sides. Now, you might want to write it underneath this equation. So you would write something like this, where you're subtracting the equation 7 equals 7 from this equation. And that's valid. It just takes up more space, so I don't write them out that way. If you want to write them out that way, if you've got enough space, go ahead. As long as you got it right. So then you get okay. That's perfectly okay. And almost everybody wants to do it that way because there are good reasons for teaching it that way. But you should also understand this way. And some people did it this way. Just depends on what you're in the habit of doing, but you've got good habits. People did pretty well on this, okay? A few little errors here and there, no big problems. So I'm real pleased with that. Okay, you got 4x equals 8. Okay. Then you write out 4x over 4 equals 8 over 4. You put down 3 dots to remind yourself that this applies. Okay, that you can write this as 4 over 4 times x over 1, and then just get a bunch of 1s multiplied and divided by x, so you get x. And you get x equals 2. Okay, good. Now people did well in these two problems, and most people did pretty well in these problems. A few people forgot the distributive law. So I'm going to remind you. Okay. Problem with this brush, you probably know better. Now, some people wanted to write this out with little things like this. Okay. That's kind of all right, as long as you remember that it's the distributive law, but I'm not going to write it out that way. I want to see the steps, and I want you to show the steps to you. At least in this course. Okay. So I write that as 4x minus 4 times 3 equals 12. Now, if you want to put those little marks on it, I mean, I did that. Okay. And it's all right, but you know, I always remembered why I could do that. Okay, so if you do this, always remember why and write it out for now. Okay, so it's 4 times x minus 4 times 3. That's going to be 4x minus 12 equals 12. Then you add 12 to both sides. So that 4x equals 24. So that 4x over 4 equals 24 over 4. I have to come up there. You got your 3 dots. Take this. And you get x equals 6. Now there is one other step that I want you to get in the habit of taking, because you learn much faster if you check your work. You just kind of automatically check your work. So we check. How do we check? We plug x minus 6 over here where x is. That gives us 4 times 6 minus 3 equals 12. Well, that's 4 times 3 equals 12. 12 equals 12, so I put a check mark on it. I know I did it right. The advantage to doing that is you get instant feedback. You check and it doesn't work. Then you know you made a mistake. You go back and fix it without somebody having to tell you you made a mistake. And of course, on a test, you check it. I don't put time limits on a test. You have time to check everything. On a test, you check it, and then you're 99% sure you got it right. Don't skip the step of checking. Okay. Now let's do the here. 4 times 3x plus 9 equals 17. That means 4 times 3x plus 4 times 9 equals 17. And then 4 times 3x is 12x, and 4 times 9 is 36. So there we are. Don't skip any steps. You want to reinforce these steps. Even if you can skip steps, it's not a good idea at this point. Not like you're in a hurry, you're trying to get the right answer. I'm not testing you for speed, although your speed looked pretty good as a Greek, didn't look bad at all. Okay, so anyhow, then we do the 12x plus 36 minus 36 equals 17 minus 36. And so we get 12x equals negative 19. Divide both sides by 12. With our 3 dots there and think, okay, I write this as 12 over 12 times x over 1 gives me 1 times x over 1, and that gives me x. So now we're confident that we can say this is equal to x. was negative 19 over 12. Then we check. Plug this in for x. And we get 4 times 3 times negative 19 twelfths plus 9 equals 17. Well, 3 times negative 19 over 12. And I'm going to write out the fractions again, make sure we understand why. That's 4 times 3 times I'm not going to write that out. Write out this. Why do I write it like this? Because I know I can divide 3 into 12, right? Now you're going to more or less skip this, but you really kind of want to think about it. And then this, couple of dots. I could write this as 4 over 4 times negative 19 over 1. It's going to give me negative 90. And then 4 times 9 is 36. That equals 17. And that gives me 17 equals 17. And it checks. Okay. Once you get used to the way you can pull products and fractions apart and simplify them, you're probably going to use simpler algorithms, but that's what it comes back to. Okay, negative 19 over 12. You're saying that's like 1.5, negative 1.58 or something like that. That's not exact. So now we can say that x is approximately equal to negative 1 point. Well, okay, 12 into 72 is 6, and it's 2. Yeah, it's about negative 1.58. It's approximately equal. Don't tell me x equals 1.58. It doesn't. 1.58 is an approximation. Okay. And then we could, divide that out further, 1.58, whatever, and then it starts repeating, and we put a little bar over the repeating part, and we have an exact solution. But don't confuse approximate solutions with exact solutions. Approximations are okay. If you want to, like if you're plotting on a graph, and you want to locate negative 19 twelfths, a lot easier to find negative 1.58. Okay. Rather than dividing a unit into 12 equal parts and counting over 7. And of course, we could also write this. This is equal. This is exact. Okay. If you're doing arithmetic with it, you want it in this form. Okay. And if you know you got enough significant figures to do whatever you're doing, it's okay to use a decimal approximation. We usually don't use mixed numbers for much of anything except locating a number in the number line. Now, sometimes we're just interested in the remainder, or you've got a remainder of 7 12, all that stuff, but let's not worry about that right now. Okay. So yeah, what I'm saying though is, uh, people have a pretty good picture of how to solve linear equations, and I don't see any reason that everybody in here can't easily complete that assignment for Wednesday. Okay, now question, still some question about, notice I use little wavy equal signs here. If you're sitting in the back, it might be a little hard to see. But, I use these. That's what I've got down here because this is approximately equal. And of course, this is straightforward. Now, open math. Some of these problems are authored by different people. And they might have different ideas about what constitutes an acceptable answer. Well, they'll pretty much tell you what's an acceptable answer. Okay, they can say you can express this as a decimal, 3 significant figures or whatever, okay? In which case, you'd want to put that into open math. And sometimes they want the fraction. They might even say the numerator is, the denominator is. They might just say express this as a rational number. A rational number is just a numerator and a denominator, both of them are integers. Whole numbers, positive or negative. So the question, what's an acceptable answer, depends on who you're asking and who's asking you. On tests, it'll be written tests. I don't test you using open math. And I also mentioned, strongly encourage that you write your work out. And if you got questions, use a scanning app or a scanner or something and send me a picture and ask. Hey, how about number 7? Okay, I got this. What's wrong? Email me that. Give me an answer. Okay. Okay, well, on a test, it's going to be written, which is why you want to write things out and prepare yourself to write your work out. You've only done a good job of writing your work out. Show all your steps, but yeah, you're doing a good job. Everybody is. On a test, I'm generally going to be looking for this. Of course, if you got a graphic, the numbers like 783 over 57, you're going to punch it into a calculator and you're going to graph that as a decimal. Don't expect you to find the right place in the number line, divide the unit up into 57 little pieces, and then count over however many there are. Okay, be ridiculous. So again, that can be used. And often is, and in most cases, it's probably useful to have at least a decimal approximation because you can see how big it is. You can't really see how big 753 over 57 is. Okay, you know, approximate 60 goes into 720, you know, so it's about 13, so maybe even 14 is 57, which is 5% less, but probably not. Okay, you don't want to think that. Although it's great if you can. Yeah, that's more arithmetic than you're probably going to be assigned to do or probably need to do. Okay. Okay, there's one more thing, one more important principle in solving equations, which is till the very last minute, you avoid fractions at all costs. Okay, fractions complicate things when you're trying to solve an equation. Now, at the end, you probably can't help but have a fraction. If you look at what we did here, we never encountered a fraction until this last step. See what happens if we have something like this. X over 4 minus 3 equals 18. Okay. The first step, whenever you have a denominator and a fraction, is you multiply both sides by the denominator. So we do 4 times the quantity, x over 4 minus 3 equals 4 times 18. What that does is it gives you 4 times x over 4 minus 4 times 3 equals 72. The equation is still balanced. I multiplied everything in the equation by 4. So everything just 4 times as big. If it's nice and balanced, it stays in. 4 times x over 4, I'll put some dots down here, but that's just x minus 12 equals 72. And the rest is just straightforward. X minus 12 plus 12 equals 72 plus 12. X equals 84. And then we take that back. And I'm not going to do that. 84 divided by 4 is 21. 21 minus 3 is 18. And you could easily write that out. So I'll do this. 84. 44 minus 3 is 18. 21 minus 3 is 18. 18 equals 18, check. Okay. You might have been taught to double underline. When you check, that's fine. Just circle it. As long as I know you understand that you checked it and it's correct, then everybody's happy. Okay. So again, basic principle. This is a heuristic. If you've got denominators, multiply both sides by them. Be more specific about that later. Okay. We're out of time, so I abbreviated the statement with them.